They're not in the nucleus of an atom. So that leads me right into number 7, and I didn't even know it. Identify the particles that are in the nucleus. Protons and neutrons. Protons and neutrons. Okay. Number 8, describe Rutherford's atomic theory and how did it differ from Thomson's? This is a question right from your Rutherford lab. We asked you to sketch the Rutherford model of an atom and Thomson's model of an atom. And Thomson, like we saw in the video thing, had this spread out positive charge or positive charges all over the place. These are plus signs. I know they don't look like it. And then where were the negative charges in Thomson's atom? All the way throughout. So there were negatives everywhere, kind of evenly distributed. That is our boy J.J. Thomson. Okay? And that turned out to be not so great. Okay?
Wait, was this the plum pudding?
That's the plum pudding. Yes, plum pudding. And you saw a plum pudding in the videos, didn't you?
It's delicious.
I posted some new.
It was actually cherry.
Chocolate.
Oh, cherry, yeah. Alrighty, and then we had Rutherford's model of the atom. And where were the positive charges in Rutherford's model?
Along the edge, like plant.
What?
In the middle?
No, in the middle. So we had all the pluses in the middle. Those are plus signs. This is Ernest Rutherford model. And then where were the electrons in Rutherford's model?
Outside.
On the outside where?
So
Yeah, out here in the outer energy levels. I only have one drawn there.
It was on the outside like planets. That's what that.
Right. Oh, okay. I did not hear that part. There's our little nucleus, and we have some various energy levels, which was actually Bohr, but we haven't gotten to Niels Bohr yet. Okay. Number 9, define the atomic number of an atom. I think we've gone over that a couple times. The number of protons. Number of protons. Is this test going to be easy so far?
Yeah.
Yes. Number 10, describe why the number of protons and electrons are equal.
So it's hard. We have to
Neutral charge.
So it has a neutral charge. Now, this question is going to be in the context of a specific element. So let's pick a fun one.
Tested.
No, something more fun than that.
How
about
Gold.
praseodymium, since Carl was all about the praseodymium. And praseodymium has an atomic number of what? This one right. 59. So, how many protons and electrons are there in a neutral atom of praseodymium? 59 protons. And how many electrons? 59. What if the answer choice said, find a darker marker, said 59 protons and 141 electrons?
What?
That's crazy.
Exactly what? The horrible answer, no. Because where's this 141 coming from?
The mass.
That's the atomic mass, and the atomic mass is not the number of electrons. But the answer choices will be something like that. So they'll throw in numbers that apply to that element, but they'll be asking about it, referencing a different part of it.
Who's that?
Number 11, define the mass number, define the mass number of an atom or a particular isotope.
The total number of protons in the atom.
Good, I'm glad you said that. The total number of protons plus neutrons. It's not the same as the average atomic mass. Okay? Average atomic mass takes in all those isotopes, and that's why the mass numbers on the periodic table are decimals. It's the total number of protons and neutrons. And there will be other answer choices that kind of reference the average atomic mass that you do not want to pick. And number 12, identify an isotope when written with its mass number. So, let us pick another fun element. What is a fun element?
Potassium.
Potassium. Potassium. Okay, so K40.
Love banana.
If I write this as K40, what am I saying? What am I identifying?
Atomic number?
Nice 40.
It's an isotope. It's potassium that has the atomic mass, mass number of 40. Okay? Now, up on the periodic table, we see that potassium is closer to 39. That just means that that might be more abundant. We'd have to go look that up in the CRC to be sure. But K40 may well exist. It's like saying carbon 12 or carbon 14 or even carbon 16, 17, or 18. Those are atoms of carbon, isotopes of carbon, that have a different mass number because they have a different number of neutrons.
Wait.
Yes?
Wait, so if I get 40 and I figure it out, I have a test, would that be right? Or would they both be right?
Yeah, the question is more about what does a symbol written like this mean? Okay, and it's telling you that that's one of the isotopes. Okay, so that is test hints 1 through 12.